Okay, so moving forward here, what I've done is essentially created a triangular shell, right? So this is sort of like a parabolic shell. Um, the important thing to note is that if you're going to use Surface Box, it actually does have to be square, which is unfortunate. So what I want to show you here is kind of just some differences about how it would look if you were to panelize a triangulated surface, or if you were to transition this into a regular NURBS surface, and then break it down into quadrilaterals, and then do the whole shell thing that way. So first and foremost, the way I'm going to start to remodify this is to change the quality of the edges. And what I'm going to do is kind of just create a lip on the edge. And I don't really have a good image. I tried to find a good image for what I was trying to do, but it didn't work out well. But you'll be fine just following along, I think. So we have these surfaces. These surfaces are made up of 3 points and 3 edges and 1 surface if we were to do a deconstruct brep. So let's do that now. I'm going to grab deconstruct brep here, plug that in, and then put a list item on the edges here. So let's take a look at this right here. So what it's doing is for every triangle, it's picking the left one in this case, and then it's picking the, let's see, that's facing that way, and the left side of that one as well. So it's left and then left and then left. So what I'm going to do is modify, it doesn't matter which one I'm grabbing right now, but I'm going to modify one edge of each of these surfaces to be an arc. And then I'm going to sort of loft those surfaces back together in order to generate a new kind of surface. Yeah, so I'll take this edge and I'll break it down into points, and then I'm going to modify one of those points, and then I'm going to remap it into an arc. And I'll do that under the curve panel, or curve tab, under the analysis panel. I'm sorry, not analysis, division. We're going to use divide curve. Have we used this yet in this class? No? Okay, cool. So this one basically just takes a curve and it divides it into equal lengths, and then it generates a point to subdivide it. So the curve I'm going to divide is this one, and you see it automatically tries to break it down into 10 subdivisions, but I only want to break it down into 2 subdivisions so that I have 3 points. So I'll do 2 and plug it in here. And the kinks input is actually just telling you, or asking you, whether or not you want to break the line at that particular, or at each particular subdivision, but I don't here, so I'll leave it at false. So what I'm going to do is I'm going to move every single one of the midpoints away from the surface in the direction of its surface normal. So I need to find the surface normal, then I need to do a move operation. So I'll do that with, and now you're used to seeing this, guys, so I'm going to kind of roll through it pretty quickly. I think you should be able to keep up. So under surface analysis, I need area, I need evaluate surface, and I need surface closest point. Area is going to be measured off of the faces. The centroid is going to be the P input for surface closest point. The faces are going to be the S. UV, P gets plugged into UV, and then the surfaces again go into that right there, the S. And that gives me my surface normal. But all of those can be turned off. Now I need to find the midpoint of each of these edge points, I guess you could say. And obviously there are 3 of them in each set, so I need to list item again with a slider of 0 to 2. So I'll just pull this thing over and plug points in instead. So index item 0 is an endpoint, index item 1 is a midpoint, and index item 2 is an endpoint. So I'm going to grab with index 1 the endpoint. Do I need to give you guys a breather here to catch up? Hearing none, I continue. So with this midpoint now, I need to move it. So I'm going to go up to transform. I'm going to use Euclidean and move. So the geometry that I'm moving is the endpoint. You'll see them kind of jump up 10 feet in the z-axis. But that's not going to stay that way because I'm going to override the translation vector using amplify so that I have direction and magnitude. So I'll go to vector, amplitude. Plug that in. The normal is the vector. The A value is going to be my amplitude. I don't know if it's going up or down here. So I'm going to do a slider from -10 to 10. So -10 is going up, so it's going to be a negative number. So just leave it at a small value, maybe 1 or 2 feet. 1 should even be fine. All right, so then here's part of the key. So I have right here, I have a move, and then I have these list item edge points that I need to grab. Okay, so I need to also grab my starting point and my ending point. I could do that using 2 more list items if I wanted to. I could go back here and just grab my 0 and my 2. That would work. See, 0, 2. Or I could go back to the original edge and I could use endpoint, which it looks like this. Just under curve and analysis, I can use this one right here called endpoints. It doesn't matter to me which one you use. Just be aware of how you're using it here. So I'm just, since I have it here, I'm just going to keep this for now. So our objective now is to reconstruct the curve at the edge. And so I'm going to kind of get down under this. We need to go from endpoint to midpoint to endpoint. So I'm going to reconstruct a curve here with primitive. And I'm going to do this one right here called arc 3-point. These are all new tools now, guys, so pay attention. Arc 3-point. It's pretty simple and self-explanatory. It just says creates an arc from 3 points. It has an A, a B, and a C. So my B is going to be the midpoint. I already know that. And then my A is the start, and my E is the end. There you go. So now what am I going to do with this in order to close this off? I have 2 other edges per every surface that exists here. Let me see if I can grab. Yeah, so I've got, this is only on 1 edge per triangle, and I want to blend it so that it's kind of a little shell on each of these triangles. So what tools do you know of in Rhino that we could use? Just shout one out to do that. If we had 3 curves, let me just kind of recreate it here. I have something like this, and then I have this. What would you use What would you use to make this a shell surface? Anybody? Anybody? Not cat. Think of like your typical surface creation tools. Loft is a good example, right? Theoretically, we could loft it, but you're going to get, oh, we did get issues with that. I forgot that it's going to loft the bottom. You could also do what's called a sweep. If you guys remember sweeps. Sweep 2 is going to let us choose first rail, second rail, and then the cross-section profile curve is that one. That's probably the one we're going to want to use for this. So let's jump into that here. And again, there are a bunch of different ways of doing that, but that's just a quick example. So let's go to Surface Freeform, and look at that, we have Sweep 2. Sweep 2 is going to ask for rail number 1, rail number 2, both of those are curves. And then it will ask for the section curve, and then it's going to ask for, what is that, same height. I don't know what same height means. That's new to me. Huh? No, shouldn't be. I don't know. Because it's a toggle, it's a true false, so I don't know what exactly it does. Anyway, so by doing this, we have to first isolate the other two rails. So we're going to do that using list item. We have the rail list items are here, so I'll grab these and copy, paste, paste. So this is one, it's another one. So let me make this rail 1 and rail 2. So simply put, we've got rail 1, rail 2, cross-section curve is this resulting arc right here. There. Whoop, we have an ordering error. Let me turn a bunch of stuff off so you can see what's going on. See that? Looks pretty cool, but it's wrong. So I'm thinking maybe my order is wrong, so let me switch this to a 2, this back to a 1, see if that helps. It does not. It should though. Hang on, let me troubleshoot this. Alright, so I'm trying a few things out, but I'm still coming up with overlapping edges. So I'm going to work on this over the next, I won't be able to work on it before tomorrow, but hopefully over the weekend I can figure out what's going on here for you guys. So let's jump back into the regular surface so that we can do this using box morph, which is the easier way of doing it, obviously.